I'm Anil Kumar, and here is question number 9 from my test paper on functions. The question is, explain if the following statements are true or false. A. Odd degree polynomial will always have odd symmetry. B. The function that is always increasing can have odd symmetry. C. A rational function will always have some discontinuity. And D is, if f of x is equal to square root of x, then f inverse x is equal to x square. You can pause the video, answer the question, and then look into my suggestion. We'll give counterexamples for showing that the statement is false. We may give examples for also showing that they are true. A. Odd degree polynomial is always, or odd degree polynomial will always have odd symmetry. The condition here is will always have, right? So it is will always have. If I give you one example which will not have odd symmetry, that means this is false, right? So if I have function y equals to x cubed plus 1, correct? In that case, this function does not have odd symmetry. If I replace x with minus x, what do I get? I get, let us say, if I replace x with minus x, let's say f of minus x is what? Minus x whole cube plus 1, which is minus x cubed plus 1. It is not equal to minus of f of x. So this is not odd, correct? I mean, the symmetry is not odd, correct? So therefore, this statement is false. Now remember, odd symmetry means that the function should be symmetric about origin, correct? So let me sketch this function. I'll make a small sketch here. If I say x cubed plus 1, then the function is kind of like this. Do you see that? It is not symmetric about origin. And therefore, it is still an odd degree polynomial, but does not have odd symmetry. The next question here is, a function that is always increasing can have odd symmetry. So always increasing, we could have a function like a straight line, y goes to x, which is always increasing, and it does have odd symmetry. So this statement is true. Another example could be 1 over x with a minus sign. For example, if I have a function like this, it is always increasing in its domain. This function is minus 1 over x, right? It also has odd symmetry. It is symmetric about origin. Next statement is, a rational function will always have some discontinuity. Let's take example of f of x equals to 1 over x squared plus 1. If you sketch this function, then let us say x squared plus 1 is kind of like this. Then 1 over x squared plus 1 will be a function like this. Now this function is continuous in its domain. It does not have any discontinuity, and it is a rational function, right? A polynomial divided by another polynomial. Therefore, this statement is false. A rational function will always have some discontinuity? No, there are many examples like this. Part D is, if f of x is square root of x, then f inverse x is x squared. Is it true or false? Well, let's look into domain range of f of x. So if I consider f of x, the domain of this function is x belongs to real numbers where x is greater than or equal to 0, correct? As far as the range is concerned, y belongs to real numbers where y is greater than or equal to 0. Now, The inverse function, the domain and range will also get flipped, correct? So for f inverse x, domain should be, it flips, is it okay? So the domain should be x belongs to real numbers where x is greater than equal to 0. Perfect. If I take inverse as f of x equals to x squared, domain has no restrictions. Do you see that? Domain is all real numbers. Therefore, this is not the inverse of square root of x. So this statement is also false. Is it okay? So the true statement will be that f inverse of x is x squared where x is greater than equal to 0. Now that makes a huge difference. So we're talking about only one arm of the parabola. Let me sketch here and show you the result. X squared is a function like this, and its inverse will be a function like this, not this arm. Do you understand? So that becomes x squared where x is greater than equal to 0. Perfect. So we have to consider only the right side of x squared as an inverse of this function, not the left side. That becomes very important observation, right? I hope that really helps you to review for your own test on functions. I'm Anil Kumar. All the best. You can always share and subscribe to my videos. Thanks for watching.